Geothermal desalination is a process to provide fresh water using thermal energy. It requires less maintenance and it mainly uses thermal energy, which has a low environmental impact. Another of its advantages is its abundance, as we can find geothermal energy all around the planet. This idea was first introduced in 1995 by Douglas Firestone, and by 2001, several experiments were done proving that we can use geothermal energy to produce water.
We're now going to talk about how engineering disciplines and non-engineering disciplines collaborate together to produce geothermal energy for the desalination of water. Geothermal reservoirs are deep underground and are usually undetectable above ground. In some cases, geothermal energy finds its way to the Earth's surface in three ways: volcanoes, hot springs, and geysers. To locate geothermal reservoirs, geologists usually drill a small well to test the temperature gradient underground. Once located, civil engineers take over to drill one injection well and one production well. Then, chemical engineers are responsible for the design and operation of industrial chemical plants. Chemists can then test the purity of the water.
Alright, so how membrane distillation works. First, you have a source of salted water which goes through the pipe and gets to the first part of the container. After that, it flows through the heat exchanger, which is powered by the geothermal energy, and then it goes to the second part of the container. And when it gets to the second part, it's basically heated up. And what happens here is just osmosis. And the way it works is the hydrophobic membrane displays a barrier for the liquid phase, allowing the vapor phase to pass through the membrane's pores. The driving force for the process is given by a partial vapor pressure difference, commonly triggered by a temperature difference. After that, the drinkable water is collected on this membrane and goes through a mineralizer, and then it becomes drinkable.
There are five main advantages of using geothermal desalination. The first one is lower maintenance than the other method. The second one is lower environmental impact because desalination plants consume a lot of energy, and the geothermal energy is renewable energy which can have lower environmental impact. The third one is we can apply it in small scales. The next one is lower cost materials because it can apply modest pressure and temperature. So the membranes that can be made of low cost polymers. The last one is the treatment can apply for higher salinity brightness.